Hello, everyone. Good evening, Sohail. Good evening. Let's wait for everyone to join. So, hello, all. Welcome back to Analytics with Anand. So, today is the lecture number 28 of Master Blastering your SQL concept on the cloud environment, which is Snowflake. So, today we're going to study a very, very important theoretical concept called facts and dimension tables, which is a very crucial topic for your interview, or if anyone is doing a transition from non-technical to technical. So, this is the questions which may appear in your interview. Right. So today is Monday. Today I'll be discussing your facts and dimension tables. Then on Wednesday, I will be discussing your ER diagram, which is the most important concept, which is in your data analyst journey, how ER diagram will help your life in working, in making your life easier while working as a data analyst in any company. So today I'll talk about facts and dimension tables in the data warehouse. And then in the next Wednesday class, I'll be talking about your ER diagram. And the next further down the line, I'll talk about normalization also. So almost your 90% of your SQL got over on this Snowflake. Remaining whatever the concepts are there, that I'll teach you there. Plus extra also I'll teach you whichever is a part of Snowflake, so that it will help you in cracking this Snowflake certification exam. So as I promised, total 40 lectures video will be there for Snowflake. I'm expecting close to 40. So let's see if we can wrap up in 35 or 38. But in and out, everything, not a single topic, I will leave it from Snowflake point of view. Because this is a very, very important tool when you join any company. Clients are working on AWS, Microsoft Azure, Snowflake. It can be any tool. So this is the first tool, or I'll say the first cloud platform which you are learning, and that too SQL you are learning on this cloud platform. So welcome back again to this Analytics with Anand. Let's see how many people have joined so that I can begin my class. Okay, Ravi Raj, sure. Many people join. So both Hindi and English, I'll keep in sync. Try to understand in English, right? Most of my classes are usually in English, because when you will interacting with the client, this is the time when you need to start building your communication skills, because you'll be a part of daily call. There you can't speak in Hindi. English is the only language. So try to develop yourself in such a way. Okay, Ravi Raj, this is especially I'm telling you for this. And those who are watching. So develop yourself in such a way so that you can be fluent in your communications. Then only your data analyst journey will suffice. I've seen many people, they are equally good in technical, but when it comes to speaking or when it comes to communication skills, they lag behind. So don't do that, right? Don't do that. It doesn't matter how good or proficient you are in your technical skills. If you can't talk, if you can't articulate things, whatever the interviewer is asking, it won't land into your favor. Okay, so start developing the skills from today onwards. So welcome back. Welcome back again to this Analytics with Anand channel. Let's see how many people have joined. LinkedIn, anyone has joined? LinkedIn, no one has joined. All have joined from YouTube only. Yeah. Okay. Before I begin, let me share my screen. One minute. Yeah, here you go. Yeah. Okay. Okay. So now this is a very, I found a very interesting PPT which has been shared by the Code Basics. I really liked the idea, the way they have represented this. This is very easy to understand. What are the facts and dimension table? What is all about in the data modeling through this visuals interpretation? You're going to love this explanation after this class. Complete crystal clear understanding you'll be having in facts and dimension table. Okay, let me take you clearly. So first of all, I will start about the data modeling. This is how your model looks. Anytime when you are working in a data analyst industry, whether you are working on the Power BI report, whether you are working on any ad hoc request from the clients, you will be working on the model, right? You will be interacting with multiple tables, which will be integrated with each other. Now, I have already explained you crystal clearly joins in all my classes. What is join? What is inner join? What is left outer join? What is full outer join? What is cross join? What is self join? All these things have been covered. Now, when you have different tables, what are the relationship between table? How these tables are joined between these? All this modeling, you can see it in the Power BI. You can also do it in the Excel. And there are various tools. I'll show you how you can do it in MySQL also. right? So this is the modeling diagram which may be given by your consultant, or you need to give to the consultant, you need to give to the stakeholder while preparing for your data model or while preparing for any Power BI report. If you open any Power BI, I think I have opened one Power BI. So if you open any Power BI report, see, this is the Power BI which I have opened, right? If you go to the data model, let me zoom it. If you go to the data model, here is the data model. You can see the modeling is there. Of course, any task, any data analyst task which you do, you have to work on models. If you are working in data science domain also, you have to work on the models, right? Clear? So this is the data model which you have to create, right? No one will create it for you. Sorry. This is the data model which you have to create, right? When you are interacting with different tables, like you have date table, you have region table, you have product table, you have customer table, you have how these tables are interacting, what is the meaning of this line, how these tables are mapped, on what primary key it is mapped, what are the relationship between them, what does star means, what does one mean, all these things we're going to discuss in this class in great detail. Okay, in great detail. So this is how your data model looks, right? How this data model looks. Who create this? Data analyst create this. This is the task of a data analyst. Typical task of a data analyst. Data analyst has to create this. Okay. Data analyst has to create this. Okay. So these are the different tables. You have products, you have date, you have customer, you have target order, and you have order line. So and so. I'm not going into much detail in the table as of now. Okay. Now, if you see this, there will be two category of table which we call in the data analyst terminology. These are called fact tables and these are called surrounded tables, right? Like you are surrounded by your friends and your family, right? So in the same way, any Power BI model or any modeling which you do, it consists of fact tables surrounded by dimension tables and all the relationship and also all the relationship between the tables. So there are two terminology, fact tables and dimension tables. But what is the meaning of this? How do we know which one is fact table? How do you know which one is dimension table? Let me take a walk through this. I have no idea, but all of this, Jenny, can you explain them in detail? That's the beauty of code basics. I really thank them for bringing this. This is a very, very unique way of explaining, I think, things here, right? Of things here. So let's understand with the fact table. So what do you mean by facts? What do you mean by facts? So it consists of measurements, metrics, or facts of a business process. It can be any measurement, right? Metrics or facts of a business process. It generally contains your transactional data. Generally contains transactional data, right? Generally, it contains transaction data. Transaction data are what, guys? Dynamic data. Every day you are doing transaction on Swiggy. Every day you are doing transaction on Zomato. Every day you are doing a banking transaction. So whatever the dynamic data which you see in the real world, all comprises of fact tables. All comprises of facts tables. So fact table has a two type of columns. Fact table will have a two type column. Those that contain facts and those are foreign key to dimension tables. Right? So fact table will have a primary key and also a foreign key. Now you have a crystal clear concept of what is foreign key and what is primary key. Foreign key is a primary key in that particular table, which links another table. So there's a linkage happening between them, right? So the primary key of a fact table is usually a composite key that is made up of all of its foreign key, right? So primary key of a fact table. So fact table will also have a primary key. Dimension table will also have a primary key. So what is the relationship? So the whatever the fact table will have, that will have a dynamic data, and whatever your dimension table will have, dimension table will have static data. Say for example, your customer table. Do you think I will be changing the customer details? No. Once customer has entered the first name, last name, place, PIN code, phone number, Aadhaar number, PAN card, or whatever the details, it is static, guys. I'm not changing further down the line until unless there is a update once in a blue moon or once in a 6 month. Suppose you want to change your Aadhaar address or passport address. That happens once, right? Not every month you will be doing it. So all the statistical data goes to the dimension table. These are called dimension table. Dimension table, it's very easy to understand. Dimension table is nothing but your static data. In layman terminology, dimension table is nothing but your static data, and your fact tables are your real data which you're going to work, real transactional data which you've seen day in, day out. Netflix, how many transactions are happening? Amazon Prime, how many transactions are happening? Who are my customers? Those who are purchasing my plan. What are these? These are all real transactional data, right? Once you have created an account on Netflix, you will never change that account, right? You will never modify that. Your email name, phone number, name will never change, right? So that are all statical data. Statical data is nothing but your dimensional data, right? Dimension table, which I'm going. So all your statistics data goes into your dimension table. All your dynamic data goes into your fact table. So two very important terminology. This is the hot favorite question for the non-tech people, right? What do you understand by facts and dimension table? So don't blabber that point. Tell your fact table contains all the transactional data, real data, which you see on Amazon Prime, Netflix, Swiggy, Zomato, all give live example. Your HDFC Bank, ICICI Bank, any banking data, any money exchange platform, whatever the transaction you are doing in and out, that is nothing but your facts table. Dimension table will nothing be having a statical data. Like your customer table. Customer table is a dimension table which will have a static data. What will be the primary key in customer table? Customer ID. Now let's come to the transactional data. Transactional data will have a transaction ID, will have a customer ID. There can be also a foreign key. There can be also a foreign key which is linked to the the dimension table, right? So the primary key of a fact table is usually composite key. Composite key is a key which applies on two different columns, right? We have already discussed that. So this is the bifurcation of fact table. Let's talk about this. Facts order aggregate. You have customer ID, you have full name, on time, order ID. Guys, order ID is the transactional data. Order every day, order you will be placing on Swiggy. Just now in the afternoon, I placed Swiggy some vegetables, Swiggy Instamart. So what are these? All are transactional data, order ID, order placement data. So this is nothing but your facts table, not the dimension table, right? And what are the foreign key here? Order ID and customer ID. Every customer can place multiple orders, right? And order ID will always be unique. Even if the customer is placing 2 order or 3 order, it has to be unique. It has to be unique, right? Does it make sense or not? It has to be unique, right? So your fact table will always be having your foreign key, right? Foreign key. And the primary key of a fact table is usually composite key that is made up of all of its foreign key, which is given in the picture. So what is the primary key here? Primary key is the customer ID and order ID. Primary key is the customer ID and the order ID. Let's see the next example. Right? Let's see the next one. A fact table stores information, things that happen, dynamic data, guys. Whatever the dynamic data you are seeing, runtime data, whatever the data you are seeing, which is flowing every single second, your stock markets data, right? Your transactional data, all are these, your fact tables. Just by looking at the table, you can see, you can tell whether it's a fact table or whether it's a dimension tables. Your sales data, sales will happen. Sales is not static. Every day sales will happen, right? Every day some people will do transaction, amount, customer ID, which customer has done what transaction on what date, which product and how much quantity they have purchased. So these are all about the fact tables which store information about things that happen. So sales is a fact table that contains sales of a store, like how many of each product were sold and how much money the store made from each side, right? So from the sales table, we get data about each transaction. How can I know which product is being sold more or which city has produced more revenue, right? Don't worry about this 1-2 star, 1-2 star. I'll explain you in this class only. Right? So fact tables are linked to other tables called dimension tables. So transaction data will be linked to some customer, no? So of course, every fact tables will be linked to your, of course, dimension tables, right? Which customer is doing the transaction? So transaction will be linked to the customer using customer ID as a primary key, right? Linkage can happen. There are various ways of linkage. You can do one-on-one, you can do one-to-many, you can do many-to-one. All this I will explain in this class. So fact tables are linked to other tables called dimension tables. Dimension table make it possible to perform these type of queries and analyze, right? And analyze. So you see, dimension underscore customer I have given. Is it static data or dynamic data? It's static data. It has city. It has customer ID. Customer ID. City, customer, and ID will never change. Once you have enrolled for a Netflix, Amazon Prime, or any HDFC bank, your ID will never change. That's for the lifetime. Customer ID will remain as it is unless you change any phone number or anything. Getting my point? So dimension table contains your static data. Fact tables contain your real dynamic data, which is called transactional data, right? So dimension table consists of attributes that describe the object of a fact table, right? Object of a fact table. It has a primary key column that uniquely identify each dimensional record. The dimension table is associated with fact table using this key. Only one key will be there. Of course, primary key, but that's not the case with the fact table. Fact table will have a one primary key, composite primary key, which will act on two different columns, right? Of course, all the static table which you create customer, say for example, country table I am creating, it will be a static. It will have only a one key, only a one column, one field, which will uniquely define records in a table, which will be a primary key. That's what it says. That's what it says. Dimension table primary key. So dimension table store information about the people who made the purchase, not all what they purchased. Who made the purchase? Who made the purchase? Who made the purchase? Here, dimension customer is a dimension table and sales is a fact table. And sales is a fact table. To make a relationship between tables, the table should consist of a column attribute. I have already discussed this in my join class. How do you join two tables? You join two tables on based on primary key, always primary key. Right here, the common column attribute is customer ID and the relationship one to many. What does star denote? Star denote one to many. Why one customer has multiple sales? Because one customer can purchase multiple things, multiple quantity. Am I right or not? Am I making it clear or not? I can purchase on Swiggy and Zomato. I am hungry. I can order on breakfast. I can order for lunch. I can order for my dinner all 3 times. So I will be having one customer can place multiple order. That makes sense. So of course, the kind of relationship which I'm expecting here is one to many. One to many. Every customer can have multiple orders. One customer can do multiple transactions. Right? One customer can do multiple transactions. So this is what will be my dimension table, and this is my fact table. So this is my dimension table, which I am hovering, and this is my fact table, which I'm hovering here. Okay? Clear? That's what I was trying to say. So this is your dimension table, and this is your fact table, and how they are linked dimension and fact through one to many. One to many. One to many. Star means many. Star means many. One to many. Okay? Yeah. Let's see the next thing. Let's see the next thing. Yeah. So what is one to many relationship, Jenny? Okay, he's asking. Okay, let's talk about this. So there are 4 type of relationship. There are 4 type of relationship. One to many to one, many to many. Now, I want all of you, those who are watching this video live or those who will be watching live later, just comment one-to-one relationship. What do you think? What is a one-to-one relationship? Give me one realistic example from data analyst point of view. One, I need all for one. What is one-to-one relationship? Where do you find one-to-one relationship in reality, in the business domain? Where do you will see one-to-one relationship? What do you think? Where you will see one-to-one relationship in reality? Anyone? Can you ping in the chat? Where you will see one-to-one relationship happening in the data analyst world? Give me the realistic example. Don't give me lame example. Give me from the analyst point of view. No. Don't tell inner join and all. I'm not talking about joins. Shrey, listen my question very, very carefully. That's why I'm telling you. Try to articulate the thing which I'm saying. I need an example. I didn't ask the kind of join. I need the example of one-to-one relationship. What can be the realistic example? Think from transaction point of view. Think from transaction point of view. What could be one-to-one relationship? What could be one-to-one relationship? Employee and their department. Very good. One employee will be linked to one department, right? One department, one person will with one Aadhaar. Yes, one person with one Aadhaar. One person will have one customer ID. Right? One employee will be associated with only one department. It cannot be associated with multiple departments. One student can have only one roll number. Yes, so there are numerous examples. Account number and customer ID in bank. Very, very good example, Aishwarya. Account number and customer ID. If one customer ID will be linked to only one account number, it cannot happen. Multiple customer ID cannot be linked. One account number and one customer ID, right? So all they are very, very realistic. So what are the type of joins in one-to-one relationship? Straightforward case of inner join I'm asking, right? One-to-one relationship is nothing but your inner join. One-to-one relationship is nothing but your inner join. State and capital. Every state will have one capital. Every state will have one capital. For sure shot, we all know that. Every state will have one capital, right? Every state will have one capital. So each row in one table has only map with one row in the second table. Each state has only one capital. Now, what about one-to-many relationship? One-to-many relationship, we are entire day associated with one-to-many. I am ordering on Swiggy. I'm ordering on Zomato. Multiple times I'm doing transaction. Morning I did Paytm, evening I did again Google Pay, and evening again, afternoon again I did my phone pay, all from the same account. One account can have multiple transactions. One people can place multiple order on Swiggy and Zomato, right? One customer can have the multiple order, right? So the customer code 17002017 in the dimension customer table is mapped with n number of rows with the same customer code in facts order aggregate. This is called one-to-many relationship. This is called one-to-many relationship. One customer can have multiple sales. One customer can have multiple sales. So this is called one-to-many relationship. Okay. Then comes many-to-one. Then comes many-to-one. Then comes many-to-one. Achha, I forgot to ask, what is one-to-many relationship? What kind of joins do you see in one-to-many relationship? What kind of joins will you expect in one-to-many relationship? Is it inner join? Is it full outer join? Is it self join? Is it left outer join? Is it right outer join? Or is it what? What kind of join? Usually you can relate this. One-to-many relationship. One-to-many relationship. What kind of join? Left join. Yes. It is kind of left join which we can talk about. Next, many-to-one. Many-to-one relationship. So multiple rows in first table has mapped with single related. Many people can place order on the same day at the same time. Many people can go for the Netflix subscription at the same day at the same time. Many people can do a transaction at the same day at the same time. Right? Then the banking domain, lots of transactions are happening simultaneously. Trillions and millions of transactions happening at the simultaneous. What is this? Many-to-one. So many is denoted by star and one is denoted by one as it is. Like multiple rows in first table has mapped with single related row in the second table. Different student getting the same grade. Lame example, some kind of lame example is here. Different student is getting the same grade, right? Different student getting the same grade. Different customers are doing the same kind of transaction. They are transferring some amount from India to US, right? $100 or $200. That can happen. Different customers are purchasing the same product. Summers have started coming. People have started purchasing refrigerator and this one AC. So multiple customer can purchase the same AC. Same, that can happen. Of course. Why not? That can happen. Okay. Many-to-many relationship. See this. I think this is from the code basics. Dhaval teaches ML and Power BI. Power BI is taught by Dhaval and them. Right? So main multiple records of one. What is many-to-many? What kind of joins are we talking about in many-to-many? Full outer join. Full outer join. Clear-cut case of full outer join. Right? Multiple records of one table are related to multiple records of another table. More than one teacher can teach multiple courses. So one teacher can be enrolled in multiple courses, right? So 1 2 star and star to 1. Can you see this? 1 2 star. See this? 1 2 star, 1 2 star. One teacher can be enrolled in multiple courses. And one course can be given to the multiple teachers, right? Like that. Different student connected to this live lesson from different countries. Yes, Nadi. Right, I think you are from Africa, I guess, if I'm not wrong. Okay, so multiple records of one table are related to multiple records of another table. Very, many use cases, right? Right, one customer can purchase multiple products, and each product can be associated with a different salesperson, right? Okay, yeah, you're in the UK. Great to hear that. Okay, so this is many-to-many relationship, right? So this like Dhaval teaches ML and Power BI. Power BI is taught by Dhaval and him, right? Clear? One teacher, Dhaval teaches teacher ID and course ID, and this course ID can be assigned by multiple course. Simple case of full outer join. Simple use case of full outer join, right? Simple case of full outer join, right? So this is the very nice PPT by Code Basics. Overview I have given. How this will look in. That I will show you here. Let me show you here. Yeah, this looks like this. 1 minute. Sorry. Let's see this. Okay. So this is the one. Now tell me, what does this arrow indicate? This is very important. In the Wednesday class, I'll be teaching about your ER diagram. In the Wednesday class, I'll be teaching about you ER diagram. So this has got very important relation. Okay. See, automatically it is highlighting. Automatically, if you put on the cursor, automatically it will highlight. Same with the Power BI. See, same. What is the date and sales? How date and sales are joined? Using date and order date. Automatically you are highlighting. One-to-many. You can right click here. And you can see the properties. You can also see the properties. Okay. Yeah, you can see the properties. How the sales and everything are linked. Right. So it is linked through delivery region index. Right. How these are linked? Many-to-one. So these are type of relationship. This is called cardinality. One-to-one, many-to-one, one-to-one, and many-to-many. Many means stars. Many means star. Again, I'll be teaching in Power BI. Everything you can see. Regions, 1 2 star. Products, 1 2 star. Now, Power BI is very smart enough. When it comes to the modeling in Power BI is very smart enough. Power BI will automatically detect. Power BI it will automatically detect. If I try to change, Power BI will automatically detect what I'm trying to achieve. Product description index, and here you see automatically it's index. If I try to change the quantity, and if I try to change this, it will give me an error. It will give me an error because Power BI is super smart. Power BI is super smart. Automatically it will give you. If you try to select wrong value, automatically it will give you the error, right? There's already a relationship between these two columns. So you need to select the correct column. Most of the case, 90% of the time, Power BI will automatically select it. Power BI will automatically select this. Okay. So this was important relation facts and this is called the ER diagram, which I will discuss in the Wednesday class, which I'll discuss how you can create the ER diagram. I'll tell you, not in today's class. Today's class, I'm just talking about facts and dimension tables. All about facts and dimension tables, right? So these are the fundamental elements that define a data warehouse. They record relevant events of a subject or functional area and the characteristics that define them, right? Characteristics that define them. So data warehouse are data storage and retrieval system. We know about database. I have already discussed in my first lecture video that support business intelligence and online analytical processing activities, right? This we know already. It is common for data warehouse to contain large volume of historical information for performing queries and analysis. It is also common for the information in data warehouse to come from a diverse range of sources. It can come from Azure, it can come from Microsoft Azure or AWS, it can come from Snowflake, it can come from Azure Data Lake Storage, ADLS, it can come from multiple sources, it can come from SAP HANA object, right? There can be multiple sources of these all objects, right? Cross-functional for discoveries and gaining insights, right? So this is all about, I have spoken about the data warehouse. Let's go down and see. Okay, let's go down and see. This is not very, very important. I want to come directly to this point. You can read this. Yes. Tables of a warehouse have some peculiarity that differentiate from those commonly used for transactional processing. In particular, data warehouse tables are divided into two main categories, facts tables and dimension tables, right? So two types, facts tables and dimension tables. So the star schema, there are two main topology, star schema and snowflake schema. Star schema and snowflake schema. So today in star schema, individual dimension surrounds a single fact table. So there will be a single fact table. While a snowflake schema has a hierarchy of dimension. Snowflake you have seen, right? Snowflake have you seen how many it contains, right? I'm not logged in. Snowflake you have seen how many it logged in. 1 minute. Let me log in and showcase it to you. So Snowflake, as might we are aware, you will be able to see all it is organized into database, data warehouse, then comes the schemas, then comes the file, right? See this, right? Informational schema, public, sales, then inside the information schema, you will be having views, certain views, then the schema will come, then inside the tables will come, right? This is the chronology, which I have explained in my beginning of the first class, right? So in data warehouse modeling, star schema and snowflake schema consist. So there are two types of schema, star schema and snowflake schema, two schema. I'll discuss this again in the next class. Star schema and snowflake schema, which consists of your fact and dimension table, right? Facts and dimension table. The fact tables, as I show, it contains all the primary key of the dimension and associated facts or measure. Property, like color, right? Suppose you went to buy a car, what you will use? Engine type, let's say petrol or diesel, right? What is the color of the car? What is the configuration of the car, right? All those attributes, right? Dimension table will be descriptive information of all the transactional information, product, place, people, right? Correct. Facts tables are the transactional table. Dimensions will be very small because customer database won't be huge. Transaction will be huge because each customer can do multiple transactions. Each customer can do multiple. Yes, this is the schema I was talking about. Time is a dimension table. Item is a dimension table because it's a static. Item key, item name, brand, sold by, category. Location is a dimension table, right? Position ID, name, state, pin code. Branch is a dimension table. These are all static, guys. These are all static data. Only is your sales table is dynamic. Look at the foreign key. FK stand for foreign key. PK stand for primary key. Item key, time ID, time is there, location is there, quantity sold, amount sold, and average sale. These are realistic data. These are transactional data, which comes under the stars, this fact table. Facts table. I told you it will contain a foreign key. Facts table will always contain a foreign key. Your dimension table will contain only a primary key, right? And this facts table will be linked to your dimension. This is called a star schema, right? This is called a star schema. Only one dimensional table will be linked to one fact table, right? Sorry, my bad. Multiple dimension table can be linked to only one fact table. There will be only one fact table. That's what was written in the previous code, right? Only one fact table, right? And dimension table can be many. Dimension table can be many. Dimension table can be many. Okay. Single fact table. We are discussing a star schema, like a star projection. Single fact table. Star schema will have a single fact table. We are seeing a single sales factor, single sales factor table, and it corresponds. It maps to item using item key. It maps to time using time ID. It maps to location using location ID, and it maps to branch using branch ID. These are all the foreign keys. These are all the foreign keys. Yes, these are all the foreign keys. Right? I'll share this file on the GitHub. Okay. So a typical star schema data warehouse schema that the fact table sits in the middle, surrounded by the dimension tables. Right? So dimension versus fact. It is fundamental to understand the difference between facts and dimension in a data warehouse for creating a flawless database design. Why do we need flawless database design? So that I can design it flawlessly. So facts are the measurable events related to the functional area covered by a data warehouse. Sales are facts in a data warehouse, right? If the data warehouse contains information about patient care in a hospital, patient visits to the hospitals are facts, right? These are facts, right? But patient details will be a dimension. Patient details will be a dimension, right? So fact tables are the core tables of a data warehouse. They contain quantitative information commonly used with points in time. They are used in trends, comparisons, aggregations, groupings. They feed analysis and visualization tools to allow insights to be discovered about the functional area. Now, dimensions are a collection of reference information about the facts in a data warehouse. It categorizes and describes the facts located to provide meaningful, descriptive answers to business questions. Statical data, right? Just like any table in a relational model, dimension tables have a primary key. I have told you already, which may be natural or surrogate, and a set of attributes. It can be a composite primary key, right? However, dimension table do not need to be in the third normal form. Normal form I have not taught you, right? Normalization also I have to teach you. For the time being, bear with me. Third normal form do their job. I'll talk about first normal form, second normal form, third normal form. So this normal for normalization and facts and dimension tables are used in the database design. So database engineer will be designing this, or database administrator will be designing it. Database developer, right? Database developer will be doing it, right? Database developer will be doing it. Okay, right? So these are the things. Okay. Okay. Let's talk about what are these role-playing dimensions. So role-playing dimension are used by different fact tables, just like confirmed dimension. But unlike confirmed dimension, they have different meanings depending on the fact table or even the field within the fact tables. The date dimension mentioned earlier as a confirmed dimension. This is the further dimension bifurcation. Confirmed dimensions, role-playing dimensions, and all. You don't have to go into that much detail. Theory-wise, I have given. Just I will read this example. For example, in the sales fact table, we may have an order date, a delivery date, and a payment date, all related to the same date dimension. All related to the same dimension. So these are different dimensions, slow changing dimensions, right? Slow changing requirements. What does it say? One difference between events and dimension is that events occur once and leave a record that they have occurred. The record stays there forever with no change of it changing. Dimensions, on the other hand, may change. Stock keeping unit attributes, some customer data, even the name of seemingly immutable things like location or institutions may change. Dimensions that are susceptible to change are slowly changing dimension. But further bifurcation, you don't have to go into that much detail. No one will ask you in the interview. No, they will ask you the just general definition of facts versus dimension table. This one, right? This was important. Facts versus dimension. That's what they will ask you, right? That's what they will ask you. Okay. Because this is for the database developer. This is for the database developer. Then there is something called junk dimension. This is important. Now, I will tell you. In the master code, I have shown you in the first class, in my all-in-one code. Do you remember? I have created certain flag. I'll show you. See this. I have created certain flag, right? I've created certain flag, right? For my simplification purpose, right? Flag I have created, right? If then why, then else. If mobile number is on, if customer has turned on the mobile number and email number, flag addressable, right? SMS, whether the customer has, whether I can target that customer as SMS or not. When, if the customer has opted for the SMS, if he has turned the mobile number on, and if his marketing flag is on. Many a time when you register on any website, there's an option while checking, do you want to receive any updates from us, right? So if you click on yes, that means I'm marketing you. I'm marketing you, right? That means you will receive all the marketing related updates. But if you are unchecking it as no, it is marked as you won't be receiving such as. So these are called flags. These are called flags, which you see it here. These are called flag. You see, yes, no, Boolean, yes, no. So these are called junk dimension. These are nothing but called junk dimension, right? The fact often have indicator at like flags. Boolean values have some other set of values that do not make sense as a dimension because of their low cardinality. Because of their low cardinality. To avoid creating small dimension for each of these attributes and increasing the number and size of fact table, unnecessarily we are increasing. A junk dimension is often created to gather all these attributes into a single table. So whatever you are seeing it here, guys, whatever you are seeing it here, all these flag, I will create one table. What table I will create, guys? What table I will create? I will create one table called dimension, opt email, opt SMS, email address, mobile number, consolidation flag, email address, all this SMS marketable, whatever you see, yes, no, whatever you are seeing, yes and no, Boolean value, I will create in one small dimension table, and I will push it, Database designer will push into that. Okay, database designer will push into that into a single table. Right? It gathers all possible combination of attributes in encompasses, identifying each combination with a single surrogate primary key. Right? It is sufficient to include a single foreign key to the junk dimension table instead of storing the value of each of the attributes. To clarify this idea, let's look at an example. Let's see one example, guys. Suppose you have a sales fact table with several indicator attributes such as frequent customer, whether this customer is frequent or not, yes, no. Whether this customer is frequent or not, yes, no, with values, yes, no. Again, with values, yes, no. Delivery code with values 1 or 2, and shipment category as ABC. What are the tag talking about? I'm talking about sales fact table with several indicators such as frequent customer, whether this customer is coming again and again. Swiggy, Zomato, HDFC Bank, any banking people, they can track it, no? Whether we are a frequent customer or not, they will have a flag, yes or no, right? Based on last transaction or based on any business logic with value yes or no. Delivery code with values 1 or 2, and shipment category with values ABC. Instead of including these 3 attributes within the fact table, we can create a junk dimension table with this structure. What do we know? We need junk dimension ID is primary key. Recent customer is Boolean. Yes, no. We can have the delivery code as integer, and we can have the shipment category as character, right? Which has this row. Junk dimension ID 1, 2, 3, 4 we are creating. Recent customer, no. Delivery code was 1. Shipment category 1. Now, this recent customer is based on the latest transaction date. Recent customer name based on the last transaction date. How do you get the guys last transaction date? Max of transactional date. Max of transactional date. If max of transactional date, suppose, is within a week, what is this recent customer? Now, this recent customer is totally dependent on the business logic. Swiggy can define this recent customer, those customers who have done transaction in last 2 days. Zomato can define this recent customer, those customers who has done transaction in last 1 day. Netflix can define recent customer, those who has purchased the plan in the last 1 week. Recent customer for Amazon Prime can be those customer who has purchased my plan in the last 1 month, right? So it depends from business to business. It depends from company to company. Recent customer logic, right? Recent customer logic, right? So this is the table I'm having, suppose, right? This is the table I'm having. Then our fact table may have a structure like this. Sales fact ID, date ID, customer ID. Just we need junk ID. That's the beauty. All the values which you are having, you have just created one small dimension table where you are having all those details, and you are linking that table with sales fact table using junk ID. Using junk ID, which you have created for the above table, right? So this is how you should be also designing the table when you are working. All the junks value which you are having, this indicator, Boolean value, you can create one table called junk dimension, which will be mostly static. right? Junk dimension table, and you can give the primary key as a junk dimensional ID, and you can link your fact table with this table using that particular primary key. Depending on the combination of junk dimension for each fact, you assign the junk ID value that corresponds to the rows with the same combination of values. Okay, same combination of values. Now, your fact tables will have two types of attributes, qualitative and quantitative. Qualitative attributes define the characteristics of a fact. They are commonly defined as a foreign key to a dimensional table. What can be quantitative? Amount, right? Amount, transaction, quantity, length of time, or any measurable quantity. Any measurable quantity, such as, let me show you, such as this. Any measurable quantity, such as this. Your transaction count, your total principal, right? All this, your total fee, your total revenue, your principal per customer, your total transaction per customer, your revenue per customer. All these are measurable numerical quantity. All this you can have as a quantitative fact tables, right? Quantitative fact tables, your total customer, your transaction count, your principal, your fee, your revenue, your principal. All these are measurable quantities. So all these measurable quantities will fall under your quantitative fact table, which you can apply statistical calculation, sum, average, and variance. That's what I'm showing you here. Any calculation which you're applying, these are called quantitative fact tables. Quantitative fact tables, right? They may be additive or non-additive, depending whether or not they can be summed across any dimension. They may be semi-additive, meaning they can be summed across some of the dimension of the data warehouse, right? So let's classify fact tables into three most important categories based on how measures are recorded. Number one, transactional fact tables. What do you understand by the transactional fact table? Your transactional data, your sale invoice, right? Much detail. So they're usually a large number of different. What does your transaction data will have? Transaction ID, customer ID, customer name, right? Amount transferred, time of the transaction. Now, every transaction which you do on Google Pay is geo-tagged these days. You cannot do any transaction. Automatically, Google Maps will get open, right? At the back end. Kindly enable your transaction. If you have turned off your Google, if you have turned off your GPS, you cannot do Google Pay transaction because it will ask you, kindly enable the transaction. Why? Because every transaction is geo-tagged. Because later on, if any fraudulent activities happen, you can you can contact your customer care number of that bank and you can ask them, right? I was in Bangalore, Whitefield. Why did the transaction happen from somewhere across other state, say MP in India or anywhere in Africa or in US? You can track it, right? So these are called transactional fact table. Then comes a periodic snapshot, right? Which takes a snapshot of events for a given time period. They commonly use transactional type fact table as a source of info. For example, they record total sales per day by summing data from a transactional fact table. Periodic snapshot. What I'm doing in this master code, which I've shared with you all. What I'm doing this master code. Sir, you are calculating financial metrics for every month. For every month. See, I'm using date trunk and I'm extracting the transaction month. For every month, tell me what are my transaction count, what are my total principal, what are my total fee, what are my total net revenue, what are my total revenue, what are my principal price. All these measurable quantitative quantities, snapshot I'm taking for that particular month. So this is called periodic snapshot. Next comes your cumulative snapshot. Cumulative snapshot fact tables are used to mark the various milestones of a business process, usually with multiple date columns. Each row in a fact table summarizes the event that have occurred between the beginning and end of a process. This type of table is useful for data warehouse that gather information from pipeline process, such as claims processing and order fulfillment. So each row of a cumulative snapshot fact table corresponds to an event in the corresponding business process. As an example, take claim tickets. As the ticket change status, claim ticket. Now, how many people have claimed, right? Swiggy, Zomato, Netflix, Amazon Prime. Again, this is valid across. The date and time of the status change are recorded in the corresponding records of the fact table, accompanied by measures of elapsed times and delays. Right? So this is all about your facts and dimension table, right? So the data granularity of a fact tables defines the greatest level of detail possible when analyzing the information in the data warehouse. More granular data allows for a greater level. More you dig deep inside, more granular, more bifurcation, more is the better. Greater number of dimensions, larger data warehouse you need, and greater complexity in query and data gathering processing. Then you need the computing power to be very, very strong, right? And accordingly, you can scale your Snowflake here, right? Accordingly, you can scale your Snowflake, right? What exactly? You can select the warehouse and accordingly, you can say, for example, you can resize it. If the warehouse size is large, extra large, large, medium, small. Already I have discussed this, right? So that's all we were talking, right? Clear? So it is challenging to change how a large physical warehouse of material and product is organized. It is challenging to change the structure of large data warehouse to avoid making insurmountable mistakes in a data warehouse. It is critical to define these two elements, facts and assignment, precisely and from the outset. This is all about the overview I have given in great detail about facts and dimension table. So fact tables are the table which holds the real transactional data, and the dimension tables are nothing but your static data, your customer name, dimension attributes, or anything, right? So this was the most important concept which will be asked you in interview. So make sure you are aware of this. In the next class, I will be discussing about the ER diagram. I will talk about all this ER diagram and cardinality and everything. So don't miss this class on Wednesday, 10 p.m. I'm telling you today itself. Wednesday, 10 p.m. we'll discuss about the ER diagram, and I will tell you how you can generate the ER diagram in MySQL, and also how you can generate the ER diagram in Snowflake also by integrating with the third-party app. I'll tell you the both way. Okay. So Wednesday, tomorrow I'm not taking class. Wednesday I'll come and I'll discuss about all this. So is it clear, facts and dimension table? Do you have a clear-cut clarity how your facts and dimension tables should be designed? Even sometimes in career down the line as a data analyst, suppose if you need to work on the small tables, how you will be designing? That's why I say always have small chunks of table. Whenever you are working on the huge data sets, have small tables, like the way I have done, right? Small tables you created, and then try to integrate it, and then try to indicate it using left outer join or whatever it is. Small table. See how I'm creating small table, right? Always have small table, and then try to integrate them. Okay. So this was a very important concept which I wanted to discuss with you all about the facts and dimension tables. I hope I have made you clear what is fact table, what is dimension table, and how these are interlinked to each other. Okay. Yeah, stored procedure I will discuss. Just wait. That is the last topic, not now. Stored procedure I will discuss. Stored procedure I will discuss. Don't worry. I'll discuss. Definitely I'll discuss stored procedure. I won't leave any single thing. Don't worry. I won't leave any single thing. Right? I have to teach you this. I have to teach you ER diagram. I have to teach you normalization. I have to teach you user-defined function. So everything I'll teach you. Don't worry. In and out, you will be mastered in Snowflake after going through the playlist. Already playlist is there so that you don't have any issue in accessing it. Go to the YouTube. Those who don't know, go to the YouTube and subscribe to the channel if you have not done so. Right? Just go here. I'll show you. And then you can go to the playlist. All the video you'll find it in sync, so that you don't have to worry at all. All the video you'll find it here, right? All video number 28 till 27. This is the 28th lecture. All in sequence you will get. Start from the lecture number 1, those who have joined you. Start from the lecture number 1, those who have joined you. All I have given, so that it becomes easy for you. And similarly, I will cover with others also. For Power BI also, same playlist. SQL also, this one. Excel also, the same playlist will go into the picture. Okay. Clear? Okay. So do subscribe to the channel if you have not done. And if you have any doubt, comment then and there itself in that particular video. Right? In that particular video, you can comment. Okay. So do cover normalization after cardinal. Yes. After this, on Wednesday, I will cover the ER diagram. ER diagram is important. Then I will cover the normalization at the end. And then after user-defined functions, stored procedure. I have told you 40 classes I need, guys. This is the 28th class. 12 more class. In 40 class, I will cover Snowflake in and out. Everything in SQL will be done. Right? Everything will be done. For everything, guys, I will teach you everything. If you go through my first video, I think you have not went. If you go through my first video, this video, channel introduction video, right? What can you see in the thumbnail? What all is given? What all you can see in the thumbnail? SQL, Python, everything is written, right? Everything is written. Even in the description, what all I have written? SQL, Python, R, Excel, Power BI, Tableau, statistics, AWS, Azure, Snowflake, Google Cloud, Snowflake, everything I'll teach you. First, I have started with this. Then I'll start with Power BI. Excel, I will start. Or what do you want me to start after this SQL? You want me to start with Python? I can start with Python, and then I can start with Power BI and Tableau. If you want me to start with Python, I can go ahead with the Python. So do let me know what you want me to do after SQL. So March, your Python will get started, right? I'm planning to finish this in the by 10th of March. I think your Snowflake will get over mostly by mid of March. Then after mid of March, I'll start with the Python. Okay. Yes, I'll start with the Python. Yeah. Python, I'll teach you complete in and out. How you can automate the process also. How you can run SQL script inside the Python. Everything I'll teach you from the data analyst point of view. Right? So that you don't have to worry at all. In a very simple manner. Yeah. Python, definitely after this Python, I'll teach you. I'll teach you Python. Now you can, all the notes, you can refer it on GitHub. Everything I'm sharing it. So just go to the GitHub and you will be having today's note also. You will be finding it. So go to the repository, go to analytics with Anand, and then you'll find here branch, go to the Snowflake branch, and you'll find all the lecture. Lecture number 27 CT you already have discussed and have uploaded it. This is lecture number 28. I will upload this also. Okay, I'll upload this also. Okay. After this, I'll start teaching Python. Everyone agrees for the Python after this 40 classes of Snowflake is done, right? Okay. And if I missed any video, say for example, by mistake, there might be a chance. Suppose I missed any topic in Snowflake or in SQL, do remind me, right? Sir, you have missed that topic. So I'll teach that topic separately and I'll add it in the playlist, right? But there will be hardly no chance that I won't be missing any topic. I'm not here to run away. This is like a lifetime. This YouTube channel is the lifetime free of cost. This will go till I think this will go till 3, 4, 5, 10 years also. After this Python is there, then your Power BI, then Tableau, then QLeak, then there will come, Excel will come, R programming will come. Everything I'll talk in detail. I'm not starting in parallel. Otherwise, it will become clumsy, right? One at a time. Let's do one at a time. First, SQL is the heart and brain of a data analyst. Then comes the Python, right? What should I learn first, Excel or Python? Excel you should learn, Mohammed Amir. Excel you should learn first. Guys, after SQL, you should learn Excel. Yes, Python I'll be teaching, but learn Excel. Excel is important. I'll be teaching you Python. And do let your friends and your other colleagues that I'm coming here live. I try to come very often. Usually I try to come every day, but I'm associated with iNeuron also. I'm associated with others institute also. So I hardly get time, but I'll try to come at least 2 days, guys. Definitely for you all. Monday, Wednesday, and Friday, I will try to come here for sure. Monday, Wednesday, definitely going further so that we all are in the sync and we can cover the syllabus at a faster pace. If you have 5 years of gap, don't worry. That you can suffice it. Learn it. Focus on that learning. Focus on the learning for the time being, right? Focus on the learning for the time being. Work on the skills. If skills is better, you will get a job. So don't worry. Focus on skills. Okay. Focus on skills. That's what I wanted to say. If you can enhance your skills better, you can, even if you have a career gap, you can do this. How do you manage your 24 hours? Fully I'm occupied. My work started at 9:30 and got over at 8:30. 11 hours I worked there. Then immediately today was my fast day. I completed my puja and then straight forward to your class. Then I hardly will get next time. Again, I have to work for my Azure certification. My Azure certification is due. So I got very, very less time. Yeah. So that's how life is. If you want to achieve something in life, you have to work really, really hard. I work close to 16 hours. 6 to 7 hours I sleep, and then 1 hour you can do all this freshen up and all. 15 hours straight away to the work and this YouTube channel and all those things. Even on Saturday, Sunday. Saturday, Sunday, I'm full tight. Okay. Just working hard, a day will come. Don't get disheartened if you are not getting any job. You will get definitely. Till then, work on your skills. Work on your skills. Work on your skills. Add in your resume Snowflake. You can mention Snowflake into your resume. Yeah, definitely. If you have gone through all my videos till now, how you get all energy for 16 hours? Eat properly. Take some multivitamins, right? Take some multivitamins. Definitely. It will help you. That also video I have shared on my Road Cycle YouTube channel. Have some multivitamins. Guys, these days I see all the youngsters, they are lacking micronutrients. Most of you will be having deficiency in vitamin D. That's for sure. Go and get checked your vitamin D. Vitamin D is the common problem in all the folks right now across the world. Everyone is having vitamin D and vitamin E deficiency. Even I was having when I started, before I started running. Do some physical activity, do some running and all. Running is the best exercise which I recommend to everyone. Any time you can run. I even run at 1 o'clock in the midnight, right? Running is the best exercise. All your nutrient deficiency will go off. And those who wants to speak to me, you need to call me after 11 p.m. IST. So after 5 minutes, 11 p.m. will be there. I'm free only after 11 p.m. I sleep close to 2 o'clock, 2 o'clock in the midnight, somewhere in the morning. 2 to 8:30 I sleep, 8:30 and 9. Yeah. Only I get 3 hours for myself, 11 to 3. That's all I have for my. And that too, sometimes students call me in that particular time and all. So you can call me after 11 p.m., not before that. No way. Either on weekday. All Monday to Sunday, you can call me only after 11 p.m. If you want to call me after 11 p.m. Okay. Chalo. Take care. Bye-bye. I'm signing off. We'll see you on Wednesday. Do join my class on Wednesday. Okay. See you then. Good night. Take care and all the best for your life and for your future. Bye-bye. See you on